Okay, so here's a story that I'm not expecting you to be able to predict. Okay, all electron donating groups are orthopara directors. We've seen that before. Going somewhere here with this, okay? They're all orthopara directors. All electron withdrawing groups are meta-directors except halogens, okay? So here's something that, again, I wouldn't necessarily expect that you would be able to predict. Halogens withdraw electrons by induction. Yeah, that you would have predicted, because in general, you figure that halogens, right, have electron withdrawing effect. Good, you've seen that before, right? That's why HCl is a good acid. That's why we have, you learn that in principles too for polarity, polar substances. I gotta start over, guys. I gotta start over. All right, 19.9, halogens, the exception. Now we're going to get into some things that I would not necessarily have been able to predict, and I wouldn't expect you to predict it either. So just in a quick review, electron donating groups, here look at this, all electron donating groups are OP directors. All electron donating groups are OP directors, right? Okay. In general, withdrawing groups are meta directors, except the halogens. And why? Why is that? Okay. So, again, looking back down here, activators, right, put substituents here. If there's an activator right here, it's going to put it at either the ortho positions or here's the para position. If it's a deactivator, it's in general going to put it at a meta position. Okay? Now halogens are the exception. I'm going to go back to highlighter. Let's play around with that a little bit. Highlighter or the halogens withdraw electrons by. Man, I'm having trouble. Okay, I'm going to start that sentence over again. Halogens withdraw electrons by induction, which you've seen this before, right? You've seen that before. Polar bonds. It's supposed to be a highlighter, sorry. Halogens withdraw electrons by induction. Halogens, however, donate, are you serious? Electrons through resonance. Okay, so there's our two ways of getting electrons into and out of systems, induction and resonance. And since they donate through resonance, they're OP directing. OP directing. All right, I better go back to my pen. This is a little distracting for me. Pen. All right, so let's look at this. Here's how this works. You've seen this picture before. So you put a halogen on here to test this out for yourself. You draw this benzene ring with a halogen on it, chlorobenzene. Now, let's first of all consider the ortho position. These electrons come over and make a new bond with this nitrogen. There's the new bond right there. Right? So we're going to get carbocation there, carbocation here, carbocation here. The resonance hybrid for this you should draw, especially if you're doing what I'm doing. I'm just checking out. My mind is just checking out right now. So if you're doing that, then pause the video and draw the resonance hybrid. Okay? All right. And can you see that if we have a carbocation here, where are we here? If we have it here, then we're going to get some resonance stabilization. Boom. See that? See how that's resonance stabilized? Then the positive charge is shared with the chlorine. Okay. Over here, you can't get that. There's no way I can put these electrons into the system, right? Because it already has 4 bonds. That's not going to happen. Already has 4 bonds. That's not going to happen. Already has 4 bonds. That's not going to happen, right? So it's not going to go meta. It's not going to be stabilized via meta, but it will be stabilized via ortho, and para. All right. So compare the energy diagrams for the 4 following reactions of benzene. Ortho nitration. Compare the energy diagrams. So the energy diagrams are not given for you in the text. You should draw them out. Compare the energy for the 4 following reaction. Wait. Compare energy diagrams for the 4 following reactions. Nitration of benzene is one of them. You've got that one. I'm sorry, that is given to you. Orthonitration of chlorobenzene, which is not given to you. This is not given to you. And metanitration of chlorobenzene. Yeah, so draw all those 4 out, and you should superimpose them. Draw all 4 out in one graph. That is like this. Going back here, the nitration of benzene, right? So you've got something that looks like this, okay? Nitration of benzene. Paranitration of chlorobenzene. That's the last one. I think ortho nitration, yeah. If you start out now with a chlorine here, suppose it starts out here, right? You're supposed to draw it out. Does it look like that? Does it look like that? And so on. That's what I'm asking you to do. And then finally, practice with conceptual checkpoints 19.14 and 19.15. All right, good luck. I'm going to try to get a little rest before I do this next video so I'm not stumbling over everything. I know that's painful to watch. Good luck with these conceptual checkpoints.